What's happening, dogs? Mr. Allen here working with some trig ratios in this video, given that a point lies on the terminal side of theta. So here's how it's usually laid out on a quiz, test, whatever. Find all 6 trig function ratios given the terminal side of theta contains the point -5, -12. All right, it could be any ordered pair, but if they're both negative, it's going to be in the third quadrant here. And I will try to draw it somewhat to scale, coming over here a little bit and going down a little bit mo. And then I will take a fancy ruler here, and I'm going to draw essentially a triangle with this to my positive or negative x-axis, whichever one it is. In this case, it is the negative x-axis. I never draw my triangle to my y-axis. It always goes up like this, or up here, or over here, or down here. It makes basically like a bow tie if you add all 4 of them. And this is going to be a right triangle, right? Because I drew it straight down, and then I have a hypotenuse right here. So if I label this, because this point here is -5, -12, if I label that, my x is this way, this is going to be -5, and my y is up and down, so this is going to be -12 for these side lengths. Not really lengths, but they are the sides of this particular triangle on the xy coordinate plane, which will allow me to then get my hypotenuse, because I kind of need that to figure out all 6 trig ratios here. Well, it's a 5, 12, 13 Pythagorean triple, okay? Know your Pythagorean triples for these, right? They come up all the time in these problems. And if you don't know them, I got you right now. There's a 3, 4, 5. That's the most famous. I use that one all the time when I'm building stuff. We have the 5, 12, 13. I'll just write it anyways. 5, 12, 13. We have an 8, 15, 17. And a 7, 24, 25. Those are the most common ones. There's like 9, 40, 41. I think that's it. I'm going to double check my calculator right now. 9 squared plus 40 squared. Square root it. 41. So 9, 40, 41 works too. But generally speaking, you're going to see these guys here or multiples of them, right? I could have a 10, 24, 26, right? I could double all of those. And you can do it with any of them, right? Okay, cool. So now let's get to work. Where are we looking at this from? We are looking at it from this angle right here. So that means this is my opposite side over here. This is my adjacent, and this is my hypotenuse. You may or may not need to label that anymore at this point in your trig, life here, because you've been doing trig for quite a while. But if you need to, throw down OAH. Doesn't take too long and makes it a little bit easier to work with things, okay? So sine, it's opposite over hypotenuse. That's -12 over 13. Boom, -12. 13, 1 done, 5 to go. Cosine is adjacent over hypotenuse. That is -5 over 13. And if you ever have to reduce, you should reduce. Or if you have to rationalize your denominator, you need to do that as well. You can't leave square roots in the denominator for whatever reason. I got beef with that, but the mathematical community says you need to. So if you have a square root, make sure you rationalize it, okay? Next one, tangent, opposite over adjacent. So -12 over -5. Am I going to leave that? No, it's going to become +12 over 5 for my final answer on that one. So make sure you do those little simplifications if needed. Cosecant, that is the reciprocal of sine. So I'm going to flip it. It's still going to be negative, but it'll be 13 over 12. We generally keep the negative either out front or in the numerator. Nobody throws it in the denominator. If you do, you're weird, right? Don't do that, okay? I will make fun of you. If I see negatives in the denominator, I'll be like, dude, see that? Do you see that, kid? It's negatives in the denominator. Just kidding. I won't do that. But please, okay? Negative in the numerator or out in front of the fraction. That is the common thing. I don't know why it bothers me so much to have a negative in the denominator, but it does. Next one. We got 13 over 5 now. -13 over 5. Let me just show you what it looked like, okay? We got 13 in the numerator. Ugh. I can't even, okay? It's going to be -13 over 5. It's so much better. Isn't that so much better? Much better. Okay, last one here. We've got flipped, and I'm just going to flip the positive one because I already know it's going to be that. 5 over 12, right? It is adjacent over opposite. For those of you that don't remember, you're like, how'd you get these ratios, bro? Maybe a little SOHCAHTOA for yourself, okay? A little SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then you're like, well, but do you have one for the reciprocals? Yes. CHOSHA. CAO. Cho, sha, cow. Boom. Done. Sokotoa. Choshikau. We're done. Thanks for watching.